Hello guys, welcome to um, another video. And in this video, we are going to do a deep dive into IKE version 1 and also IPSec. So we are going to trying to make you understand how these two technology work together to form a site-to-site VPN connection. And this is for the CCMP security exam, the SIMOS security exam. Which I know is going to expire in February, but I'm trying to get it before that. So let's go ahead and, like I said, do a deep dive into this world of IKE version 1. Okay, so IKE version 1 is the Internet Key Interface, and the Internet Key Exchange um, is actually the Internet Key Exchange. I don't know why I put the Internet Key Interface. It is the Internet Key um, exchange is a protocol used to set up security associations or SA in the IPSec protocol suite. Okay, IKE builds upon the Oakley protocol and ISAKMP, and IKE comes in two phases. Um, the first phase, which is the scope of phase one, is to negotiate a secure transmission channel between VPN endpoints. Okay, so between two endpoints, which means that between the two routers in phase one, the two routers are trying to negotiate a VPN transmission. Um, and the first thing that they're trying to do is that they're trying to find a common secret key that comes via the Diffie-Hellman exchange. Additional keys that derive from common secret keys. And phase one, what it does is it secures parts of phase one negotiation, and it is in there to secure the phase two negotiation. Okay. And phase two negotiation is IPSec, of course, which we are also going to talk about. Phase one, there's a couple modes in that you can run in phase one, which is the IKE version one configuration. And you can run either main mode, which is the default, or aggressive mode, right? Um, in main mode, usually seen in site-to-site VPN connections, it uses a three bidirectional message exchange or six unidirectional. The first four messages are in clear text and the last two are encrypted. Um, if you want to protect the identity of the endpoints, you want to encrypt the last two messages. Aggressive mode, usually seen in remote access VPNs when we're using IKE version 1 or IKE version 2. Well, IKE version 1, it is Cisco does not recommend anymore. Actually, you won't be able to do IKE version 1 on remote access VPN. Okay, but it uses three unidirectional messages. The last message is encrypted, but it's not mandatory. In site-to-site VPN or in main mode, it is mandatory. And it does not protect the identity of the endpoints if you do not encrypt the last message. And the phase one negotiation parameters. During phase one, here are the parameters that we're going to be negotiating and that need to match between the two endpoints, right? So authentication, encryption, hashing, and Diffie-Hellman group number. And there are negotiated parameters that do not need to match, which is the SA lifetime, which is in seconds, which is a common secret key lifetime, and it is negotiated to the lowest value between the VPN peers. Phase two, we are going to talk about on another PowerPoint. So we are done with IKE version 1 and what the scope is, right? It's the main scope is it secures part of phase 1 negotiation, and it secures phase 2 negotiation, which is to do the IPSec. And the main mode and aggressive mode are the two modes for phase one. And here are the parameters that we're going to be negotiating. So let's go ahead and configure that phase one. And this is to build an IPSec or a site-to-site VPN tunnel. So let's go ahead and do that. Let's go ahead into router one and also bring up router two. And we are going to form, or we're going to create that phase one config T. So the way that we do that is by doing a crypto ISAKMP. ISAKMP stands for just IKE version 1, okay? And then we have to create a policy. And after we do that, we need to create a priority policy. Let's just call it 1. And in here, what we need to do is we need to negotiate the parameters. So they need to match between the two endpoints. So between router 1 and router 2, they need to match these parameters that we're going to configure now in the policy. So we need to configure the way that we're going to authenticate, the encryption method that we're going to be using, and the hashing, and also the Diffie-Hellman group number. So let's go ahead and do that. Encryption, we are going to be using 3DES. Hashing, which we're going to be using MD5. Um, Group number, which we're going to be using group number Diffie-Hellman group number 2. And the authentication method, which is going to be using, you can do a question mark, you can use a pre-share key, an RSA ENCR, which is a Rivas, Shamir, and Alderman encryption, or a RSA SIG, which is Rivas, Shamir, and Alderman signature. But we are going to use a pre-share key because we don't have a RSA, right? And this, everything we configure right here needs to match with router 2. So if you do show crypto ISAKMP policy 1, or do show crypto policy, you can see that we have configured um, a policy, which is policy 1, with the priority of 1, right? And we have set that the encryption algorithm that we're going to be using on this endpoint is going to be triple key des hashing algorithm. It's message digest 5. The authentication method is going to be the pre-share key. Diffie-Hellman, we're going to use group number 2, or 1024 bit. And the lifetime we left it as default because it doesn't really need to match. So let's go ahead and do the same on R2. Config T, crypto, ISAKMP, policy, 1, encryption. Remember, it needs to match, so we need to do 3DES. Authentication needs to match, which is a pre-share key. Group number, 2, it needs to match. And the hashing also needs to match, which is MD5. And if we do a do show crypto ISAKMP policy, you can see that these two are matching, right? Because they need to match. Otherwise, we won't be able to create that phase 1 of the site-to-site tunnel, which is the IKE version 1, as you can see right here, and it is matching between the two routers. So then after that, since we said that we are going to be using a pre-share key for authentication, we need to go ahead and create that pre-share key. The way that you do that is a crypto ISAKMP key. Now we need to give it a value, CCMP security, and the address, and this needs to match the IP address of the other endpoint, which is router 2 IP address, which is 20.1.1.2. There we go. So now we need to do the same over here. Do a crypto ISAKMP key, the value CCMP security because it needs to match, and then the address 20.1.1.1 because it needs to have the address of the other endpoint. And there it is. So that has been configured. Crypto ISAKMP key CCMP security, and crypto ISAKMP key CCMP security. So that has been configured. If you want to do a show command, you can do show crypto ISAKMP, I believe is key. There we go. So we have a key for the remote for the other endpoint, which is 20.1.1.2, and the pre-share key that we configure is CCMP security, and it needs to match with this other end. So if we do a do show crypto ISAKMP key, or do show crypto ISAKMP key. Yep, there it is. The remote address of the other endpoint, 20.1.1.1, and the pre-share key, which is CCMP security, and they need to match. Otherwise, they won't be able to form tunnel the first phase one, right? Which is the first tunnel that we are creating with IKE version one. So we are done with the configuration of phase two of phase one. So now let's go ahead and talk about phase two, which involves IPSec. And what is IPSec, right? You'll be saying, well, while some of the um, above protocols can span between sites and provide some segmentation, they don't necessarily protect the data itself. The reasons for IPSec is to add that extra security. And some of the benefits of IPSec include confidentiality with encryption, integrity, right, which it is a built-in mechanism to protect and discard any data that may have been altered in transit, authenticity, which is the verification of who or what is sending the data, and zero dependability on application. Those are the benefits of IPSec. In IPSec, um, you could either use the authentication header, or you can either use the ESP, which is the encapsulated security payload. And like I said, IPSec has two options that you can use. The lesser used authentication header, we're not going to be using that, and the more popular encapsulation security payload. And we're going to dig into the difference real quickly. The first one, authentication header, nobody uses that. It gives you anti-replay protection, data integrity, and authenticates the data's origin, but does not provide data confidentiality, so it does not encrypt the data. Doesn't work with NATs and uses IP protocol 51. Now the encapsulation security payload, which is the one that we're going to be using, it provides anti-replay, the same as authentication header, data integrity, the same as authentication header. It also authenticates, the same as authentication header, but it provides encryption and data confidentiality, which authentication header does not do. And it uses something called NAT-T or NAT traversal to work with NAT, and it uses IP protocol 50. And here how the authentication header um, IP packet looks like. So here's the original packet, IP packet. It has the IP header, TCP header, and the data. What it does is it adds two extra or one extra header, which is the authentication header. It puts it right in between the IP header and the TCP header, and that way it sends its data, but it does not encrypt it. And here how um, the encapsulate the ESP encryption works. So this is the original packet, and here is in transport mode because there's two modes in ESP. One is called the transport mode packet, and in here what it does is that it adds a ESP header inside the TCP data so it could be encrypted, and then it also adds this ESP authentication in here, and it uses the same IP. So when you're using a transport mode packet, the you the people will know the origin of the IP address, and some people do not want that. So that's why a lot more people uses the ESP tunnel mode packet, because what it does is it puts the entire um, original packet inside the ESP header and trailer, right? So that way everything is encrypted and they will know where it is coming from. And then it just adds a new IP header at the end in the ESP authentication. That way everything inside the original packet or the original IP packet is encrypted, and if people are sniffing the traffic, they won't be able to know the original IP address from where it is coming from. Okay, and here also why you could use authentication header and ESP at the same time, and here is just how it looks, and not a lot of people do that. Okay, and like I said before, there is two mode in ESP. One is transport mode and the other one is tunnel mode, like I show you over here. And in transport mode, the IPsec encrypts the traffic between the two hosts. Here, there will be encryption only for the data packets and not the IP header, like I said. However, in tunnel mode, the IPsec creates a virtual tunnel between two subnets, and this mode encrypts the data as well as the IP header, and that's why our dedicated engineers prefer the tunnel mode in most VPNs, because the original IP header will be encrypted and will be unknown for people sniffing the traffic. And here are some disadvantages for IPsec. And one of the greatest disadvantages of IPsec is its wide access range. And giving access to a single device in IPsec-based network can give access privilege for other devices too, which is not good. And here's an example. For instance, imagine that you are connecting to a corporate network from your IPsec-based home network. Here, if any of the computer in your home network has malware in it, it can be easily spread to the computers in the corporate network, which is why a lot of people uses remote VPNs now. They do not use IPsec. And there's also some compatibility issues. IPsec does not provide support for multi-protocol and IP multicast traffic, and every dynamic routing protocol, with the exception of BGP, relies on multicast too. And to support multicast, you should use IPsec over GRE, which we're going to be doing in this video. And it also uses a lot of CPU overhead. Um, like it says right here, IPsec is well known for the high CPU usage. And also it has some scalability um, disadvantages. And the more IPsec connection you need, the more tunnels you have to create, and you need to administer those tunnels. And it is only a point-to-point, and since it is only a point-to-point, it does not support multicast traffic. And this is it on this PowerPoint. So let's go ahead and configure. This is phase two of the site-to-site configuration. If we go ahead and go into this, let's go ahead and do also this PowerPoint over here that I have. So for IKEv1 phase two, which is IPsec, which what we were talking about, you can only run in one mode only, and which is quick mode. And quick mode has three unidirectional messages, which secure through keying material of phase one. Okay, so phase one protects phase two. So IKEv1 protects IPsec. And here are the parameters that are going to be negotiated, and they also need to match just the same as in phase one. And this is what you want to protect and how you want to protect. So if what you want to protect is you can either do a proxy ACL if you use an encrypto map, but since we're not using a crypto map, we're using IPsec, this doesn't matter. And how to protect it, we are going to be setting up the transform set. And inside the transform set, this needs to match. So we need to match the encapsulation protocol, ESP, or the authentication header. And like I said before, we are only going to use an ESP because AH does not provide data confidentiality, so no encryption here. And you can either have a null encryption, use dash 3 dash AES GCM, AES GMAC, and also hashing MD5 SHA1 SHA2, and the tunnel mode, which is tunnel or transport. And like I said, tunnel in tunnel mode, you won't know the original IP header, and in transport mode, you will know the original IP header. And some of the negotiated parameters that do not need to match is SA, and the lowest values are negotiated, and N highest values need to initiate the tunnel. And here is how the control plane um, works in IPSec or Phase 2. Or in Phase 1, the control plane always starts on UDP 500, and if NAT device detected, NAT traversal is negotiated and it is changed over to UDP 4500. And in Phase 2, IPSec control plane follows up on Phase 1. If Phase 1 finish on UDP 500, we are going to use UDP 500. And if Phase 1 finish on UDP 4500, then we are going to use UDP 4500. Okay, so we already went over this stuff, like I showed you in the other um, uh, PowerPoint. So let's go ahead and configure the Phase 2 of this site-to-site tunnel. So if you do a show crypto ISAKMP policy, we can see the policy. We do a show crypto ISAKMP key. The key is there. So now let's go ahead and configure Phase 2. And to configure Phase 2, the first thing that we need to do, we need to do a crypto IPSec transform set. And we are going to just name it tset. And over here, we need to do the way that we're going to provide data confidentiality or encryption. And then we need to do data integrity with SHA, and we're also going to be adding HMAC. And the tunnel mode that we're going to be using, or mode, is going to be tunnel mode, okay? So that is the first part. Then after that, what we need to do is we need to do a crypto IPSec profile. And this IPSec profile, we are going to just call it IPSec profile. Enter. And then after we do that, all we need to do is just attach the transform set that we have created. So you do set transform set, and we want to attach that tset that we created. If we do a question mark, you can see you can add a description, you can set the default commands and do some redundancy and responder only, or set some parameters. If we do set, you can see that you can set the group, the identity, IKEv1 profile, ISAKMP profile, which we are not um, using, mixed mode, reverse route, and all that good stuff. So if we do exit, let's go ahead and say this crypto ISAKMP profile. We're not going to be doing that, but if you were configuring a IKEv1 profile, this is the way that you could do it. Okay, so let's go ahead and end it. Do a show IPSec, or show actually crypto IPSec profile. You can see the profile that we have created. And also if we do a show transform set, IPSec transform set, you can see the transform set here as well. Use an ESP256 AES and ESP SHA with HMAC for data integrity, and this one is for data confidentiality. And we are going to be negotiating the mode of tunnel. Now let's go ahead into router 2, and let's go ahead and configure that crypto IPSec transform set. We are just going to call it tset, and we're going to be using the same as router 1. So AES with 256, ESP with SHA and HMAC. The mode is going to be tunnel. Then we are going to create a crypto IPSec profile, and we're going to be calling this just IPSec profile. The names do not need to match. I'm just making it to match so I don't get confused. And then we're just going to set the transform set, and we're going to add the transform set that we have created. And then we're going to end it, and we're going to do a show crypto IPSec profile, so we can see the profile that we just created, and also do a show crypto IPSec transform set. There we go. And as you can see, it is matching. We are using the default. We're not using the default, which is transport. We are using this one, which is ESP256 AES and ESP SHA with HMAC. And you know that we're going to be using the this transform set that is called T set. It is, if you go to the IPSec profile, you are going to see that we're using the transform set, which is the T set. Okay, all good, all good. So moving on, and like I said before, IPSec by itself does not support multicast like EIGRP or SPF or any of those dynamic routing protocols. And for us to be able to add dynamic routing protocols, we need to add a GRE tunnel. And the way that you do that, you just go ahead and do a tunnel interface tunnel 0. And over here, we need to set the tunnel source. And the source is going to be the IP address from where um, we are going to send that traffic, which is gigabit 00, which is connected to the endpoint of router 2, right? And then we need to do the tunnel destination, and the destination needs to point to the other side or to the other endpoint of router 2, which is 20.1.1.2. 20.1.1.2. There it is. Okay. So after that is done, you need to do a tunnel mode, and we are going to use IPSec with IPv4, and then we need to configure an IP address for this tunnel, 50.1.1.1. Otherwise, it's not going to work. And lastly, we are going to attach um, the IPSec profile so we can encrypt all the traffic that is going to go through this tunnel. So you're going to do tunnel protection IPSec profile, and we call this IPSec profile. And then ISAKMP is going to turn on. There we go. ISAKMP is on. After that is done, we are going to just exit and do router ERP, because now since we have this tunnel, right, we are able to route or to send multicast packets. Therefore, we are able to send EIGRP or this dynamic routing protocol called EIGRP. And let's just do no outer summary. The network that we need to add needs to be the network of the tunnel that we created, which is 50.1.1.0, right? And then the other network that we want to add is our local network. There we go. So we have added the tunnel. We are now going to add this gigabit interface right here because we don't want it to go through the interface, because if we go through the interface, we won't be able to use EIGRP. We wanted to send it through the GRE tunnel because GRE tunnel supports um, multicast traffic. All right. So let's go ahead and do the same on router 2. Config T interface tunnel 1. Let's do a tunnel source, and the source of router 2 is gigabit 00, which is a one pointing or connected to the other endpoint of router 1. And then tunnel destination is going to be the IP address of the endpoint of router 1, 20.1.1.1. Then we need to do the tunnel mode. Since we are going to use IPSec, we just put IPSec right here. And we are going to be using IPv4, so you just put IPv4. Then we configure the IP address 50.1.1.2. And then we do the tunnel protection, which we are going to be using an IPSec profile that we configure, and we call this IPSec profile, so we can encrypt our data going through this tunnel. There we go. ISAKMP is on. The tunnel changed to step up, so that's good. Now we need to go ahead and do a router EIGRP so we can send our multicast traffic through the tunnel, and so we can form a neighbor relationship. and we need to say, do we need to use the same autonomous system for EIGRP? Because that's how it works. For OSPF, this number does not need to match, but for EIGRP, it does need to match. Now, auto summary. The first network, I want to add the local network, which is 10.10.10.0. And then the other network is going to be the tunnel network. And after that, it should form a neighbor relationship. And here it is. As you can see, the dual 5 neighbor change. Now we have a neighbor, which is 50.1.1.1 or tunnel 1. So we have formed a new neighbor relationship. If we do show IP EIGRP neighbor, we can see that we have a neighbor relationship with router 1. And if we go on router 1, and if we do a show IP EIGRP neighbors, we can see that we have a neighbor relationship with router 2, okay, via the tunnel interface. Since it is via the tunnel interface, everything is going to be encrypted because we added the IPSec profile to that tunnel. And that's how it works. And you can do a show IP route, and you can see that if I'm going to send traffic to 10.10.10.10.0, it's going to be sent via the tunnel. Therefore, since it is going to be sent via the tunnel, the traffic, it is going to be encrypted, and also yeah, it is going to be encrypted for router 1. But for router 2, it's going to be a little bit different. Show IP route. The one that is going to be encrypted is whenever we send traffic to 192.168.1.0, which is via 50.1.1.1, which is tunnel 1. Okay. So now if you want to see your configuration or IKE version 1 phase 1, you can do a show crypto ISAKMP SA for security associations. And you can see right here that we actually have two 20.1.1.1, 20.1.1.2. Let me do a show IP interface brief. Okay, so we have two with this destination and this other destination. Believe, let me make sure that my tunnel was configured correctly. Let me do a show run. I think this is from my previous configuration. So destination, it is correctly. Okay, so it has formed two. Let's go ahead and go to router 1 and do a show crypto ISAKMP SA. And we also have two, so that is good. And that is for IKE version 1 phase 1. If you want to see the IPSec or the phase 2, you can do a show crypto IPSec SA, which we're going to do in a minute. Show crypto IPSec SA. And here it is. The IPSec SA, which is for phase 2. And as you can see, we are already sending packets. This is how many packets have been encrypted and decrypted, so 58 and 48. And you can see that the local endpoint, the local crypto endpoint is 20.1.1.1 for router 1, and the remote is 20.1.1.2 for router 2. The MTU is 1500, and the IP MTU is also 1500. And the source is gigabit00. Diffie Hellman, and all that stuff is good over here. So it is working the way we want it. So now what we want to do is we can also do it on router 2, show crypto IPSec SA. You can see right here it has sent 61 packets that has been encrypted and decrypted 71 packets. We see no errors, so that's good. You can see the local crypto endpoint 20.1.1.2, and the remote crypto endpoint 20.1.1.1. The path MTU 1500, the IP MTU is 1500, the source gigabit 00, so it is working good. If you want to see that it is working, let's just go ahead and go to router 1 and do a show crypto IPSec SA again. You can see that it has 1078 packets. So if we do a ping and we want to ping 20.1.1.1, and if I ping 20.1.1.1, since whenever, let's just go ahead and do so you can see what I'm talking about. Show IP route. If we do a show IP packet or show IP route, you can see that with this, what's going to happen is D means that it's using EIGRP, right? Because we're using EIGRP on that tunnel, and it's going to send it via the tunnel. And remember, we attach the IPsec profile to that tunnel, therefore it's going to be encrypted. So if you go in and do a ping, let's go ahead and ping 10.1.1.1 or 10.10.10.1, and we're going to repeat it 200 times. And then we're going to do a show crypto IPSec SA. You can see that it has encapsulated 292 packets and decapsulated 292 packets. Therefore, the tunnel it is working. Let's go ahead and do it. Repeat 200 more, and you are going to see that it's going to increase by 200 more. So you can see that it's working. And if you go to router 2, you can see right here that it also increased by 400. And it's also it is increasing by itself because AirDRP sends hello packets. I think, if I'm not mistaken, it is every maybe every 10 seconds or every 5 seconds. I cannot recall that from my CCNA um, studies. But also, if you want to see the traffic being encrypted um, live, you can do a debug crypto engine packet. So you can see that those hello messages are being encrypted. You can see that we cannot see what's going on because we are using IPsec to encrypt it, and therefore you won't be able to know what is going on because it is being encrypted, right? So let's just do on all. There it is. Also, if you want to do a capture, so let's go ahead and like sniff this network. So we're going to bring Wireshark. See if we can sniff the network, right? See what's going on. And as you can see right here, ESP, it is working. So whenever you click on ESP, you can see that everything is being encrypted. So you cannot read anything in here because it is being encrypted with ESP, right? And you can see that those packets that are actually that they keep sending, this is due to EIGRP sending hello packets I believe every 5 or 10 seconds. Okay, so this is it for this video, guys. I hope you guys enjoyed this video. I hope you guys learn a lot. And if you guys have any questions, what you could do is you can just go ahead into my Twitter account and just ask me anything at CCNA Daily Tips. Follow me and then ask me anything. If you did not understand something, and then I can explain it to you a little bit better. Okay? And if you don't have a Twitter account, go ahead and create a Twitter account and then follow me on Twitter. Also, subscribe to my channel. And if it is better for you to just leave a comment on my YouTube channel or on this YouTube video, you can go ahead and just do that. So this is it for this video, guys. I hope you guys enjoy this video. I hope you guys learn a lot, and I will see you on the next one, guys. I love you guys very, very much. Bye bye.